Yes, hello. I'm Ibrahim Tomasili, and I'm going to take you through the overview of the project you're looking at. And the project is basically titled as a Sign Language AI Project for Infectious Disease Screening. So basically, we are looking at a system that would help in screening infectious diseases and also help the deaf that can't speak or can only use symbols to communicate and get help from the medical personnel using a given tool to, since most chemical health personnel may not know how to communicate with them. So uh, the motivation for the project is basically bridging the healthcare gaps for the deaf, and then so the solution we are bringing in is an AI-driven sign language diagnostics, and then the components we're looking at for this project are the large language model for symptom screening, and then the LVM for sign recognition. So the diseases we are targeting are malaria, TB, HIV, and Ebola for the start, and then maybe we can look at the other diseases as we try to scale up. Maybe the picture review of the project is this. So we have the hearing impaired person who can easily make a symbol, but I cannot speak. I can make signs and signs for communication. So this is the camera that can be used to capture the symbols that are made by the deaf or by the hearing impaired person, and then the symbol is then captured and then fed into the system. The tool that we have based on the database that is data is in the database, and the algorithm, and what is behind the algorithm and the models. So the system, the sign language translation system is capable of translating or annotating and coming up with the text and audio that can mean what the impaired person is communicating. So the text and the audio is then transferred to the normal person who can read and listen. So this would help the normal person to give a feedback, so or record a new gesture. If at all he understands the gestures, then he can also recreate a gesture and give a feedback. Also, for the medical personnel that don't know the meaning or how to use how to communicate through the gestures, so they will communicate back to the system through an audio or text, and then the system can then give a feedback to the impaired person by either gesture or text if at all the impaired can read, and then that's overall how the system will be working. So what are some of the natural language processing components that will be consisted in the system? So in summary, we shall have the data. The data we shall use is basically clinical text, patients' conversations, Ministry of Health guidelines. So this is basically the data that we shall incorporate in training the model and incorporate it into the system. So we shall do tasks like annotation, prompt engineering, and translation, and this will be done onto the data to make sure that it is specifically okay. So these are the tools that we shall be using for These are the tools which are used to perform the tasks, the annotation and preprocessing, prompt engineering, and translation. So this is a breakdown of how these tools will be helping us in performing those roles with those tasks. So Prodigy is an annotation UI tool, so this will be helping us to create high quality labeled text from sign language. And then Spacy is a natural language processing tool which fixes grammar and extracts structure. So since we all know that the grammar for natural language is not the grammar for sign language, so this Spacy comes into under such a point whereby if at all the grammar of the sign language is not similar to that of the natural language, so Spacy comes in to fix the grammar and helps make complete the grammar of the sign language to natural language with all the right words that are necessary for the communication to be fit. Then for quick UMLS, so this is basically looking at the medical concept of the project. So since there are some medical terms that will be included, so the quick UMLS comes in to link the sign translations, the medical concepts, and then NLLB. So this is no language left behind. So this is a multilingual model that was trained on a number of languages. So this helps us to translate the output, which is basically the English output, to a number of languages. Since it is trained on 200 plus languages, so this tool will help us to be capable of training this model, this tool, to be able to communicate in a number of languages. So for the vision components, we shall have sign language video corpus, which is basically videos of signs. So we shall do recording, gloss annotation, and augmentation on the video corpus. So some of the tools will include Elan, CVAT, and MediaPipe and OpenCV. So this is a breakdown of how these tools are going to be used and how they will be used in the project. So OpenCV, this is basically for image processing in such a way that it helps us in capturing the video. That's the very first part of the gist of the project. Then frame processing, so it creates video frames, and then during visualization. And then for the Elan and CVAT, these are annotation tools which are basically for annotating sign language videos with the labels. It's like attaching labels to videos or video frames. And then the MediaPipe is for vision tracking in real time in such a way that it gives real time landmark of the images or the videos. Then looking at the LVM, which is the large vision model, this is basically a deep learning model that is trained on visual datasets to understand. So the main point of the LVM is basically to understand the images the videos, and the vision language tasks. So basically, the main concept that is behind LVM is looking at the videos, images, and then understanding them and give a brief understanding. So the capabilities of these models are the LVM is detecting the objects and landmarks. Then two, understanding the gestures and scenes. Since sign language has a number of points to put into consideration to get meaning of the word or with a symbol, so we have to understand the gesture, that's one, and then the scenes of the gesture, when the gesture is made or how it is made, something like that. Then joint vision language reasoning, so what it says and what the language says. So this is one of the capability of the LVM. And then for the ethical consent, so we shall need consent from the signers and contributors. So the signers are the ones that helping us create signs, and contributors are basically all of them that I will be translating and giving us signs and maybe monitoring, giving us an overview of how we interpret things. Then also how we should need ethical consent and consideration on cultural sensitive dataset development, and then inclusive technology principles. So we have to put all these principles or ethical considerations into place. Then so this is a demonstration of how ELAN is done. So since we said it is an annotation tool, so this is basically for audio and video. So we can see that this is a video. Then we have when we upload this video from the local machine, we have a point here and we have a feature here for annotating this video. So we play here, we play it, and then record, and then make annotation for given frames. Okay, then for MediaPipe Studios, then this is basically you upload an image or record a video, because it has a feature that activates the webcam or the camera that you're using. So when it sees the image, it identifies the given symbols or the given landmarks in the visualization. Then okay, so these are some of the challenges that can be looked at when exploring the tools. So aligning signs, gesture, and text in real time. Okay, this would be a great challenge, since the tools are a number of them that are performing every part. So aligning a sign, that's another tool. Aligning the gesture and then transferring it into text. So then for aligning the gesture into a text, it is specifically still hard time. Then interacting with the new interfaces. So since all these tools have different interfaces, and then others consist writing code, so this was a big experience, and okay, it was basically challenge since it involves going back to know what every interface does, and then grasping what every tool does. Then low accuracies, and for low accuracies, limited. These tools are limited to known poses and signs. For example, the MediaPipe Studio, the image that was indicated, the system took it to be a selfie, which was actually not a selfie. It was a sign for it's a sign for communication. So if the system could recognize it as a selfie, so this would hinder our communication or our translation. So this would give false communication to the impaired and the dictor, and others that wouldn't serve our purpose. Thank you very much. I conclude from here. Thank you.